Artificial intelligence is burning through capital at a pace that no traditional business model can sustain. When you train a large language model, you are not just paying for compute time, you are paying for access to a volatile marketplace where the price of a graphics processing unit can shift dramatically in the span of a single hour. This is the reality of cloud infrastructure today. For the average developer or startup, the complexity of managing these costs is a silent killer of projects. You launch an instance, you start your training run, and you assume the bill will be predictable. But the cloud market is not a static utility. It is a dynamic ecosystem where supply and demand fluctuate based on global load, regional availability, and the specific type of hardware you require. This is where the concept of GPU Compass becomes critical. It is designed to be an open-source, real-time aggregator that tracks pricing across more than 20 different cloud providers simultaneously. The goal is simple. It is to reveal the hidden cost traps that exist in mixed cloud architectures. To understand why this matters, we have to look at how pricing actually works in the current landscape. Most cloud providers sell compute based on time. You rent a GPU for an hour. You pay for that hour regardless of whether the chip is working at full capacity or sitting idle. This time-based fee structure creates a massive disconnect between what you are paying and what you are actually consuming. Ian McDougall, in his research on Agora, highlights this exact issue. He points out that newer GPUs with higher memory bandwidth are disproportionately expensive compared to their older counterparts, even when the older chips are sufficient for the task. This means you might be paying a premium for capabilities you do not need. When you are running a large language model, you need specific memory bandwidth and compute throughput. If the pricing does not align with the actual usage, you are subsidizing inefficiency. GPU Compass attempts to solve this by aggregating data in real time. It looks beyond the list price and examines the spot market volatility. To see if this tool actually delivers on its promise, we subjected it to a live stress test. The environment was an active large language model training run. This is a workload that is sensitive to latency and interruption. If a spot instance gets preempted, the training job can fail or require a checkpoint reload, wasting days of progress. We ran the test across a mixed cloud architecture, utilizing different providers to find the cheapest available instance at any given moment. The results were startling. The volatility was not just theoretical. We observed price swings of 36% in some regions within a single day. This volatility creates a significant arbitrage opportunity for cost-sensitive workloads. Emerging alternative cloud providers are aggressively undercutting the major hyperscalers like Amazon, Microsoft, and Google. They are doing this by up to 36%. However, this savings comes with a risk. The smaller providers might not have the same reliability guarantees. A tool like GPU Compass has to balance the cost savings against the risk of interruption. During our test, the tool successfully identified instances that were cheaper than the standard spot market rates. It flagged opportunities where an instance was available for a fraction of the cost of a major provider, provided you were willing to accept the potential for preemption. However, the real challenge is not just finding the cheap instance, it is managing the heterogeneous scheduling. Zhang and colleagues argue that using homogeneous GPUs is suboptimal for large language model serving. You might have a mix of older and newer chips available. Some are better for training, while others are better for inference. A static pricing model cannot account for this. GPU Compass, in theory, allows you to route tasks to the hardware that offers the best price-performance ratio at that exact moment. This means you are not forced to use the most expensive GPU just because it is the standard offering. You can dynamically select the resource that matches your workload requirements. Consider the case of a small to medium enterprise. They often cannot afford enterprise-grade cloud instances for every task. Tharwani and Perkayastha note the architectural differences in general compute instances across different clouds. What works on one platform might not translate to another. The Blackwell Guide suggests that local consumer-grade Blackwell GPUs can rival enterprise cloud instances for specific inference tasks. This shifts the strategy from fixed per-hour instance models to granular per-token cost calculations. If you can calculate the cost per token generated, you can see that consumer-grade hardware might be the most cost-effective solution for certain workloads. GPU Compass helps bridge this gap by making the pricing transparent enough to make these calculations possible. Without this transparency, you are flying blind. You might end up paying for an instance that is underutilized because you do not know a cheaper alternative exists. Orchestration tools like GPU Stack are becoming critical infrastructure to automate this selection process. They allow you to define policies, such as always choosing the cheapest available GPU that meets the minimum memory requirements. This automation is what turns raw pricing data into operational deployment. It removed the manual overhead of constantly checking prices and migrating workloads. The stress test revealed that while the savings are real, the complexity is high. The tool had to manage the trade-off between price and stability. In some cases, the cheapest option was a spot instance that was preempted twice during the training run. This forced the system to restart the checkpoint, losing some progress. In other cases, the tool identified a stable instance that was only marginally more expensive but offered significantly better reliability. This decision-making process is where the tool adds value. It is not just about finding the lowest number on a price list. It is about finding the lowest cost for a successful outcome. The market is moving towards a future where cost efficiency is defined by granular metrics rather than broad categories. The shift from fixed per-hour models to per-token calculations is essential for the longevity of AI startups. If you cannot predict your burn rate, you cannot scale. GPU Compass represents a step towards that transparency. It aggregates the fragmented data of the spot market into a single source of truth. It highlights the disconnect that Agora describes, where resource price does not match resource usage. By exposing this, it allows engineers to make informed decisions about where to run their workloads. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.